Okay, so we're going to start with lesson 3-2 today. Or a new lesson, yay. And this is solving equations by graphing. Now, there's some elements to this lesson I'm not super thrilled about, but there's some elements that I think are really important. So the first being we have some vocab that's important to understand. Now, we don't deal with it as much in Algebra 1 as you will be dealing with it in Algebra 2, okay? So this is sometimes we just do introductions. So the first vocab is called a linear function. Now, that one we are going to deal with a lot. And we talked about functions before, and we had some rules about functions that each x has to have its own unique y. That makes a difference between a function and a relation. But a linear function is like a linear equation. Its graph is going to be a line, okay? So that's basically it. So it's a function, so it meets the rules of a function whose graph is a line. Okay, now when I write an equation, a linear equation, it looks just like this. Y equals, and then something happening to the x, and then maybe something happening afterwards on its own, a constant. So this is your linear equation. And presto changeo, to make it a linear function, we just do a little sleight of hand, and this is what we end up with. The function at x equals 2x plus 3. And we had talked about that nomenclature when we were talking about functions before. So this is now the linear function. Okay? So the big aha is when I see y, it means the same thing as f of x. When I see f of x, it means the same thing as y. So they're just kind of interchangeable. Okay, so that one is a term, yes, definitely we use. The next one is one that we don't explore as much in our class, and it's called a parent function. We will deal with it slightly. So if you think about your parent, they are the beginning of your family, your immediate family. And then you guys branch out, and then your children will branch out from you, and so on and so on. Now, obviously, your parents had to have parents, otherwise they wouldn't be here. But if we just looked at your immediate family, your parents would be the start of your immediate family, okay? So a parent function is going to be the simplest possible function for that type of function. So could anyone give a guess what they think the simplest linear function is that we can write? No bells, no whistles. Max?
X equals what?
No. Remember what a function has to have. So f of x, what? So say it again.
F of x equals x.
That's it. So the parent function for us in functions is f of x equals x. So that's the parent function. Okay. Now, like I said before, the parents generally aren't the end of the story. They create a family. So I'm going to show you some family members of this parent function. It could be things like f of x equals 2x. So now I've added a coefficient to my x. It could be f of x equals 2x minus 1. So in addition to a coefficient, I now also have a constant, okay? It could be f of x equals 3x plus 5. So it's not always a subtraction. Now I should add back over here parent function of a linear function. Not all parent functions go back to f of x equals x, okay? Different types of functions that we study have a slightly different parent function, okay? So these are called family functions. Of the, oops, sorry, I always do that. F of x, function at x, is equal to x, okay? I'm going to bring up a vocab word and something we did, chapter 1. People did not do well on this. X-intercept is one of the most important reasons why we learn to graph, but it also is known by other names. Can anyone think of another name for an x-intercept? And again, we got tested on this. Ben?
Root.
A root. Okay, that's one. We got two more. Max?
Zero.
A zero. That was one everybody was confused on. So think of it, x-intercept. When does the y value equal 0? That's kind of where that comes from. And there's one more. Oh, this is the one that we use all the time. Not necessarily for x-intercept, but for an answer. What's that guy? Oh, I can't have one person who just knows. Jekar?
Ordered pair.
No. No, not always. It's a more generic term than that.
Yeah.
Okay, Kim?
Solution.
A solution. Okay. So, bottom line, all of these have this in common. Where the graph intersects the x-axis. Okay. Now, how do we find the x-intercept or root or 0 or solution? Okay. And we have two choices. And I'll be honest with you, the first choice is the smartest one, because it's the fastest one. That would be solve algebraically. Solve for x. When y equals 0, solve for x. So, keeping in mind, that's your ordered pair for every x-intercept. So, substitute in 0 for y, solve. The other one, solve graphically. And it must be graphed. So this is the kind of lame one, because a lot of times you can... So as I was saying, that this last one is pretty lame, because you're like, well, what if I just calculate it in my table of values, which sometimes happens. And what if I'm a really lousy grapher? I may not actually go right through the x-intercept. But unfortunately, you're going to practice a couple of this tonight. And what this really is going to relate to is when we get into system of equations. I think you guys did this last year, is when you had two equations you needed to graph and you needed to see where they intersected to find the solution. So it's along the same lines, except for where is it across the x-axis. So this is just a necessary evil. I apologize. So let's go ahead. I'm on my second page. So I'm just going to title again. So 3-2, solving linear equations by graphing. Oh, sorry, wrong date. Okay. So the main thing that we're going to do is to solve each function algebraically. So basically, and again, these are still kind of weird, but the main thing is that you're going to solve for the x-intercept. So when the y equals 0, okay? So here's what these questions look like. 0 equals 2/5 x plus 6, okay? So basically what's happening here, oh, where's that equal coming from? Sorry. Oh, plus 6. Is that this guy is really f of x. But because he's going to equal 0 because of the x-intercept, sorry, don't need that. Has a 0 for the y value, okay? So what we're going to do is just get x alone. That's all that this problem's asking us to do. So we're going to go ahead, I'm going to use the symmetric property and rewrite it. 2/5 x plus 6 equals 0. I'm going to subtract 6 from both sides. I get 2/5 x equals negative 6. I'm going to multiply both sides by the reciprocal. Since it's a fraction, I see some renaming that could take place. And then I multiply, and I get x equals negative 15. So basically, the graph intersects the x-axis at x equals negative 15. Okay? So again, a big point to this set of notes is just having you understand what they're asking you to do. So on this one, I want it to be 0 equals something with an x plus 6. So what I'm going to do is get everything onto one side and 0 on the other. So I'm going to subtract 3x from both sides, and I'm going to subtract 7 from both sides. That leaves me with 0 equals negative 6. And then I have to ask myself the question, when does 0 equal negative 6? Never. So there's no solution here. So what kind of graph would not be solvable for an x-intercept? Jackson?
A horizontal line.
A horizontal line. So the graph never intersects the x-axis. It's a horizontal line. Okay. So that's something else that's weird. Now I'm going to go to the next screen for me. You guys have plenty of room on that page. On the second page you should be on. And we're going to solve the equation graphically. Now, the weird thing is with the numbers they give us, often, if you choose Rosner's Special 3, you end up getting not only the y-intercept, often the x-intercept shows up, okay? 3x plus 1 equals negative 2. Well, for us, oh, sorry, I forgot directions here. Directions are going to say, solve the equation graphically. So the first thing I note is it doesn't quite look like what it should. So we're going to do the same thing. We're going to get 0 on the left, and then we're going to have everything else on the right. So I'm going to subtract 3x from both sides, and I'm going to subtract 1 from both sides. So what I'm left with is 0 equals negative 3x minus 3. Okay, now remember what that 0 means, right? That's your f of x equals 0. Okay, so it's going to help us describe our y value, basically. Remember, f of x is equal to y. Okay, so it's basically saying y equals 0. Okay? All right, so what we could do to make this be a little bit easier to understand, because that 0 is a little off-putting, is just replace the 0 with f of x. So I'm going to go ahead and graph, starting with coming up with a chart of values. And then I'm going to write f of x here. So my ordered pair is going to be x and f of x. Now I'm going to choose 0 because I like that one. And I'm going to do things a little differently. I'm going to choose 2, and I'm going to choose negative 2. Okay. So f of x is equal to negative 3 times 0 minus 3. So I get 0 take away 3 equals negative 3, and I'm going to be graphing 0, negative 3. And then I've got f of x is equal to negative 3 times 2. And then I'm going to subtract 3. So I get negative 6, take away 3 is negative 9. So, oops, sorry. So then I get the ordered pair of 2, negative 9. And then I would have f of x equals negative 3 times negative 2, and then minus 3. And that's going to give me 6 minus 3 equals positive 3. So the last one I'm going to graph is negative 2, 3. All right, so now I'm going to put in my graph. And I'm going to graph these. So let's see. I'm going to put in my tick marks. So x, y. So here's 2, here's 4, negative 2, 2, negative 2, negative 4, negative 6, negative 8, and negative 10. So I'm going to take my 3 points, 0, negative 3. And this one, if you don't have graph paper, then you're going to have some problems. And then 2, negative 9. And then negative 2, 3. Oops. And if we're an accurate grapher, come on you. It doesn't like me making. It seems that it crosses the x-axis at negative 1. So what I'm going to do is test out what happens when I put in negative 1 for x. So f of x is equal to negative 3 times negative 1 minus 3 equals 3 take away 3 equals 0. Okay? So that is my x-intercept because I get, that's going to be true. All right? So that's, again, totally lame. I think that this is a much harder problem than it needs to be, but again, they're going to ask you to practice. So, in words, the solution is -1. And that means the graph intersects the x-axis at x equals -1. Now, do you understand why I didn't choose my Rosner 3 special? Anybody? What if I chose -1? What would the answer have been? It would have been 0. So in my chart, I would have had, mathematically, I would have calculated the x-intercept. So that's why I did not include it in here, just because I wanted you to see this is, we don't always guess the number, but for whatever reason, 0, 1, -1, generally speaking, it may show up in that. Okay, that's it.